Hey everybody, this is Mr. Schultz here, and we are going to take a look at our new section 7. So we're starting a new section here, so 7, 2, and 1. So we're going to talk about how do you transform sine graphs, and hint, hint, we'll be getting into cosine and tangent and doing all that type of stuff too. So let's take a look what that looks like. So in problem 113 here, as you've seen with many functions in this and other courses, x generally used to represent an input and y is used to represent a corresponding output. By this convention, the trigonometric functions should be written as y equals sine of x or cosine of x or tangent of x, so on and so forth. But beware, something funny is happening. With your team, examine the unit circle in the three graphs below. What do x and y represent in the unit circle? So in the unit circle here, x would represent your kind of horizontal distance there. Y would represent your vertical distance. And so that just kind of goes around. Sometimes it's negative in the horizontal distance, sometimes it's negative in the vertical distance, and so on and so forth, going around there. And then here, so what do x and y represent in the unit circle? So x would be the horizontal. That looks like a K there. Horizontal. The Y would represent the vertical. All right, so what do they represent in each of the graphs? Be prepared to share your ideas. So each of these graphs here, we're to look at that stuff here. So if this point was 0, well, that would have or if this is the start here, my x, or my horizontal distance, would be a distance of 1, and my height would be a distance of 0. Well, here I notice my height is a distance of 0, and this is, but notice that this is in pi. So this is actually talking about the radians, and radians. So 0 radians would be starting right here, and then the height is still my height in y here. So I would have a 0. That's why I'm starting from 0. But then when I get to out here, my height is all the way up at 1. Well, look at that. It is at 1, and that is at pi over 2 radians. It's halfway between pi. And then when I get back down here to pi radians, so that'd just be 1. So that'd just be 180. Now again, my height is still 0. So basically just on the unit circle, the x versus the graph are the only thing that's really changing there. The unit circle is just that horizontal distance. The y is the vertical, and that's still the same there. But on the graph, the x represents the radians, or the radian distance. You could actually do this in degrees as well, but on these three specific graphs, it is all talking about the radian distances there. Okay, so in problem 7-14, we're just going to investigate what do we know about transformations of graphs to transform y equals sine of x and y equals cosine of x, and get that kind of general equation. In CPM, they've talked about this idea of parent functions. Lots of these ideas are going to serve and kind of hold weight when we look at sine and cosine graphs, and just kind of what goes on there, and we'll get that kind of general form. So let's take a look at this, and we'll look at this through the further guidance, which is the next question. So in the further guidance in 115, it asks you to sketch a graph of at least one cycle of y equals sine of x, labeled the intersects, go through, and then just try to make all these changes here. I think that Desmos does an awesome job of being able to kind of make those changes quickly here. So let's see what this looks like in Desmos. Okay, so we're going to take a look at this. So I've got sine of x here, and I've got it just going right now. I've got it going from down here. This is at like negative pi-ish right down here, out to about 4 pi. There's a little bit that cut off here, but I just have more than one cycle here, just kind of show that. So if we think back to our parent graph stuff and just kind of, hey, how did we get our parent graph stuff? Well, if we wanted to shift things, we just needed to add it right to the end. And look, that it moves up. Let's actually do this like this. We'll go we'll go here. We'll go sine of x, and I'll do this in my second one. I'll just go +1, and notice that, hey, it slid itself up 1. And one of the cool things about Desmos is that you can make it be some sort of a letter, then add a slider, and you can kind of see a little bit easier kind of how that graph is moving. So that's not too crazy. Like, that's just moving that thing up and down. So now that is shifted 3 units up. So if I want to go 3 units up, this can go off my graph, but it would look something kind of like that. I would just need to say, hey, I added 3, in this case 2.9. So let's go back to 3. I added 3, and now it is going to move up. Now, reflected across the x-axis. This is my next one here. So if I'm reflecting it across x, I kind of need it to be the opposite of x. So I'm going to go here, and I'm just going to keep my plus 3 there, and I'm going to try to reflect it. Oh, okay. Yep. Just like that. I should have the opposite of that reflection across the x-axis. It is flipping over there. So that would be my next step here would be that. And then my next one, shifted 2 units to the right. Again, this is just a parent graph thing where if we're trying to go to the right, we said, okay, I'm going to the right, that's positive, but with x's, I need it to be the opposite. I'm going to say -2, and now that's going to slide it over there. Again, I'm going to put this into a letter just so that you can see this hopefully a little bit easier here. So when I'm not shifting it by anything or when I'm going up, it's just shifting it to the right there, and we're going to shift it over 2. And remember, this is always opposite because it's inside of the parentheses there. If I was saying to add 2, which is what minus a -2 is there, that would be adding 2, which is roughly close stuff there. And then our last one here is vertically stretched. So let's take this out here. So now we're looking for something that's got a vertical stretch to it. So when we did that, we generally just had something we needed to multiply out front of this thing. I'm having trouble finding that there, so I'm just going to do it like that. So I'm going to go 4 times by my sine of x function. And now that is going to kind of stretch it out or kind of pull it out in the vertical direction there. So hopefully all those movements are pretty familiar to you. It's the exact same idea as when we had these x squared graphs. And you said, oh, hey, if I wanted to shift it up, I just needed to add that there. If I wanted to shift it to the right, then I needed to get inside of this x and just do that. And now can I shift it over? It's all that same information there that we had before. We just needed to go and do that. So shifted, we're just adding something. I'm gonna write this down. We're just gonna add something to the end of it. So I'm just gonna do the sine of x. I'm gonna reflect it. I need to take the negative x. Let's use x, but I need sine out front of that. Sine of negative x. That's gonna make it do the opposite. If I wanted it 2 units to the right, I'm doing these all with the sine graph, but they all work the same with the cosine, and then vertically stretched. I did times by 4. You could do times by 2. All that type of stuff, and that's just going to make that grow faster. So when we go back to this and we think about which points are there that are most important in the graph of sine here, let me pull this up. Sine of x. When I think about that graph, so important points to me are some of these that are crossing. So like, hey, when does it switch from the when does it switch from increasing to decreasing? Where's its center line? Some things like that. Where's it starting from? Different pieces like that to me tend to be kind of the important part of the important part of the process here. So if we are going to write the general equation for the parent function for this is generally kind of how it goes. There'll be a few more things that we'll add to this, but for right now, we're going to do it like this. Y equals a, that's that vertical stretch, sine, let me try that again, sine of x, oh my gosh, sine, S-I-N of x, but then we've got that horizontal movement, so I'm going to just call that minus h, just like we did before, and then plus k, that is our vertical movement from there. So that's everything that we got for today. Hopefully most of the stuff here is pretty straightforward. It's all the same rules. It all applies. It's just a different function or a different operation is the word that I'm looking for there. Have a good rest of your day. And don't forget to check out the review and preview. Once again, have a good day.